So number 21 and 23. Okay? By Tuesday, I will accept only handwriting. Yes, handwriting. Do not type, do not print. Okay? Just using handwriting. Number 21 and 23. Okay? This is one. Yes, just two questions. It's just the two questions. But in case the database is such a simple, we can draw by hand. Your homework can be drawn because it's a very simple database. It's a simple requirement. However, first time when I joined the project, the first project that I joined, it's a long time ago, 1995. At that time, so you know the PM, what PM is? It's a project manager. So I entered the room of the project manager. That his room is quite small, but around the wall, he printed all the ER diagram, but it covered all three sides of the room. He said he has more than 2,000 entities for the database. And more than several thousand, the relationship, and more than 10,000, the attribute. So it's not possible to draw each and everything. So definitely we need the help of software. So there are many software that can support such a conceptual design. This designing tool is not only for database modeling. It can be used for software engineering. Many of them actually support programming also, which means when you design some entities is automatically create the object, program part, component. So what you need to do is add logic only. Okay? Variable already defined. For example, the rational loss in IBM, it's very expensive tool. It's more than several thousand for a copy, but that helps a lot. That can save. So these are the tools for design. Among them, we are going to use Win software, Win software in CH8, Computer Association Company, which is the most popular one in real project. So when you graduate, when you get a job, when you join any real project, many of the students will use such a Win software, Win software. So we will practice the ER modeling using such a Win software next class. Okay? Any questions so far? Bunch of questions, but first try the homework. Okay? Benefit of using the Win ER modeling entity relationship, as you can see, is very easy to use. Okay, concept is very simple. Also, it can represent most of the data that you are going to manage, build. Also, it's very similar to relational model. So that is the reason we select the ER modeling. However, ER modeling is not actually very flexible. Also, it's not good for some object-oriented concept. So we will discuss about such a drawback or shortcoming of the ER modeling, then find the solution, how to address the problem of the ER modeling. So first, the problem is let's take a look at the employee. So we define the employee. We find the employee because our customer is the simple idea. So employee, he or she like to keep track of the employee name, employee social security number, and salary. That's it. However, we got another customer who are very picky about their data. Like the employee, we have the different types of employee, like the secretary, technician, and engineer. Also, he'd like to manage whether this employee is a manager or not. Also, he'd like to want whether this employee is hourly salaried or the full-time or part-time. Okay? Then the manager will be related to the certain project, and the part-time employee will belong to some union and so on. Okay? Using ER modeling, can we represent the different types of the employee? No, we do not run such a different types of employee. Instead, we need to create secretary employee, technician employee, engineer employee, something like that. Also, for the manager, we need to create the manager information as the relationship or attribute. What about the hourly? It can be attribute. So, ER modeling cannot handle such a thing. So, to address that problem, we try to little bit extend the idea of the ER modeling. That is called EER, extended or enhanced ER modeling. So, let's go back to the basic. So, when I was very young, like 5 years old, 6 years old, when I learned the language, definitely it's a mother tongue Korean language, my mom probably said a lot, like when I have the apple, so my mom said, this is the apple, this is another apple, this is another apple. So the apple is rounding, and sometimes blue color, sometimes red color. It has something very shiny outside and peel out, then you can eat. This is the apple fruit. Then, when from my mom, I probably learned about the apple, even though at that time I do not use the dictionary or definition. I define myself. Apple is this kind of thing. So, from the apple, this is one apple, one apple, one apple, one apple, another apple. Then I can define the concept of apple in my brain. Okay? So from the example, we can learn something concept. Also, after I build the concept, when I see a new apple, I can easily say, this one is the apple, even though I never seen that apple before. But using my knowledge, I can say, this one is the apple. Right? So this is actually two important things, two important way how human being learn something. How can human being be trained? So that is called, this one is generalization. You can generalize into specific concept from the example. However, you cannot see all the example worldwide. Even though if you go to the grocery store, when you pick up the apple, that is new one. You never seen that apple, but you know that is an apple. How? Because you can specialize. From the concept, you can specialize. This one is the apple. So generalization and specialization are very common, very popular, very important process to learn something. That is the same thing in the database and data that you are going to manage. Like for example here. Employee from the secretary, technician, and engineer. These are the type of employee. Then you can generalize into what? Employee. These three are the employee. All of them are employee. Right? So we can generalize into employee. Or from employee, you can specialize. Specific type of employee. That is secretary. Sometimes technician. Sometimes engineer. That is called specialization. So there are specialization and generalization process in the data. Unfortunately, ER modeling cannot represent such a thing. So we try to adapt idea of object-oriented concept to ER modeling, that is ER modeling. How? Like the superclass and subclasses. And Then inheritance. What is the inheritance in object-oriented concept? It's a kind of copy, clone. Then it will have the specific, but general information are the same, common. Okay? That is inheritance. Superclass and subclasses. Okay, like the parent and children relationship. So you will get the DNA of your parents. It's a copy of your parent, but specialized. Your sibling, probably, even though you and your sibling from your same parent are a little bit different, but still common thing. So that is super and subclasses relationship. That's called. Okay. So who will represent such a super and subclass? There are a lot of such a relationship in the data when you build a database. But ER modeling cannot represent such a thing. So how can we represent? Who will look? So we have first employee entity. You identify the employee entity. Okay? So your customer provide the employee information, so it's easy to identify this one. When you take a look at the list of employee, you realize that there are three types of employee. One is a secretary, another one is technician, and third one is what? The engineer. All of them are what? Employee. So we identify the name, social security number, and DOB, and address. Okay? Also, secretary have social security number, name, and so on. This one also has, however, common thing will not put over here. Because common thing is generalized into employee. Instead, secretary has the information about typing speed. Technician has technician level. Engineer has engineer grade. Each subclass, specialized one, has own characteristic, own attribute. Also, there are common attributes. Common attribute will be here. So how can you represent this one? Make the relationship? No, they are the actually same entity, employee. So we will create the super and subclasses relationship with the circle. Then connect, like this way. There's no relationship. This one indicates super and subclass. How many entities do you have here? Only one. What is that? Employee. But it has subclasses. How many? What is the key of this one? Name or social security number. So you can put over here. What is the key attribute of this? Social security number. Because it's an inherit, it's a common attribute. But we do not put the SSN over here. Okay, because they are common. And technician, only tier, but still SSN. All information technician has. So this is a so this is a super and subclasses. If you include these super and subclasses in your ER diagram, that's called EER diagram. Extended, or sometimes called enhanced. At this time, you may have two options for these super and subclasses. One is D, another one is O. That indicate disjoint and overlap. That means I'm the secretary as well as technician. So one employee may include here and here. Sometimes all of them, right? That can be possible because I'm the employee, but I'm also secretary, I'm also technician, I'm also engineer. If you allow such a multiple participant in the subclass, in other words, overlap, that is overlap super and subclass. However, if you do not allow such a multiple participation, only one of them, that's called disjoint. There are two types. One is disjoint, another one is overlap. Also, there might be a single or double line over here. What that means? So full, same thing, mandatory or optional. That means some of the employee does not belong any of these. I'm not a secretary, I'm not a technician, I'm not an engineer, I'm just an employee. At the time, if you allow such a thing, it's a single line. Otherwise, in other words, if you do not allow such a employee, but it should be at least one of these is a double line. In other words, it's a full or partial. So there are 4 different types of the super and subclass. One is a full participation plus disjoint. Full participation but overlap. And partial participation and plus disjoint. Partial plus overlap. So there are 4 different types. Okay, you need to specify that. And also, the last one is when you design this entity, employee, first you identify employee, which means your customer provide employee information, so employee entity. Then you realize there are 3 different subclasses, so you build the 3 and disjoint and build the full. For example, from this to down, this is called specialization process. So at the time you can put this symbol, the curve, from here to here. Or sometimes your customer provide secretary information, technician information, as well as the engineering information. But as a designer, you realize all of them are employed. So that is called generalization. In case of generalization, is this. However, in database modeling, we don't care whether this is generalization or specialization. Actually, no way to represent that one. So this is only for the EER modeling option. In database, we don't care. So that is the generalized. So extended, enhanced modeling. We will discuss a little bit more about this, and then we will move to the relational modeling. So conceptual modeling is done. Then the next class, so I will finish the ER modeling and EER modeling. Then I will explain. I will start the relational data modeling. Okay. So you have the former, that is 21. Chapter 7, 21, Chapter 7, 23. Okay? I will not accept any printed copy or soft copy, so you don't have to email me. Just bring the homework to the class. I will collect. Okay? Yeah, next class, Tuesday. Yeah, Tuesday.